Suppose I want to find the domain and range of a rational function. These are the steps. Graph the function, identify the asymptotes, write the domain using the vertical asymptotes, and write the range using the horizontal asymptotes. Let's use, for example, the function, and we'll go ahead and graph the function 4 over x squared minus 6x minus 16. Okay, and if we graph that, we can, looking at the graph, we can see that there are 3 asymptotes, 2 vertical and 1 horizontal. Let's identify. There is a vertical asymptote at x equals to -2. X equals -2. So there's a vertical asymptote right there. I want that to be a little thick line like that, and let's change the color. Red. Okay. Good. Make that a little bigger. Okay. There's also another vertical asymptote. Notice these are vertical asymptotes. There's another one at x equals to 8. All right. And let's go ahead and change this attributes as well. It's a little thicker. And all right. So those are my 2 vertical asymptotes. Okay, there's one there, one there. Okay. And let's see. So I can write my domain using these 2 vertical asymptotes because they cut the number line here into 3 sections. And so one section, if I'm writing the domain, first of all, let's go ahead and label asymptotes here. All right. So let's see, I need new actions. Okay. These are my asymptotes. These are my vertical asymptotes. All right. And since those are my vertical asymptotes, then my domain is going to be, I'm going to go from -infinity. Oops, don't want to do that. So, -infinity, I need an infinity here. Let's see. Right. All right. All the way to the first asymptote we encounter, which is -2. All right. And we want to get the middle part of the line past the first asymptote. That is from -2 to 8. That's the middle part. Okay. And then the third part is from 8 to +infinity. And we got this from using the vertical asymptote. And since we need all 3 of these pieces together, then I'm going to use the union symbol. It's like a U. Just have to scroll to find it. Where is it? There it is. All right. And I need a couple of those. All right. So we got the domain of the function from the vertical asymptotes. Okay. All right. We're going to do the same thing with the range because there's a horizontal asymptote. All right. if you look at the function from the y-axis, you'll see that there is an asymptote. It never crosses 0. Y equals to 0. So I have a horizontal asymptote and y equals to 0. And let me go ahead and add that in. And let's see here. See if it'll let me type it here. All right. And looks like that didn't work. Let me do it another way. I won't graph it as a relation. At least I won't graph it that way anyway. Let's see. And let's erase the equal sign. And we want y equals 0. There. Okay. That's what we want. So that's our relation here. There is y equals 0. That's that horizontal asymptote. So if I can just borrow this text for a minute, well, instead of having a domain, I just need text. All right, now we can find our range. And our range goes from -infinity to 0. Okay, remember we're looking at y equals 0. And as you can see, our range goes from -infinity to 0, skips 0, 0 to positive infinity. That's looking at the y-axis. Okay, with the domain, we look at the x-axis. With the range, we look at the y-axis. Okay. Also, this would be a reminder of a few things. All right, we grabbed the function, we identified the asymptotes. We wrote the domain using the vertical asymptotes, and we wrote the range using the horizontal asymptotes. Holes occur when a rational function has a common factor and its numerator and a denominator. Since the denominator does not have 4 as a factor, there are no holes in this graph. So if you look at the graph of the function here, I'll go back to it. Right here, notice that the numerator only has the number 4. And even if you factor this denominator, you're not going to have 4 as a factor. They don't have any common factors, as a matter of fact. So there are no holes in this graph. And that concludes the exercise.